Basically, we've got a big challenge. We're in between the wine tour and this presentation, and we can't be more funny than John just was. So I think we just keep it simple. We'll use the 30 minutes, but we'll do a bit of explanation about what VisionWaves is and what we do, just by telling what our customers do with the software that we have been building, and then show you some of the live stuff, demo, in terms of the front end, the business users, but also how we create the stuff and manage the stuff on the back end. So that's basically what we would like to do with you for the next 30 minutes. So let's move on, because all of you probably have a big information overload anyway, and we are just going to try to stuff more into you for the next 30 minutes. First, who are our customers? And what is the problem that we are solving? Basically, our customers are large enterprises, and they are looking for a new kind of problem because they want to be more agile, they have to lower costs, they have to be more compliant, they have to increase their Net Promoter Score, making customers happy, and this time they have to do it all at the same time. And those are conflicting goals. So what they have to do is become smarter, like a smart machine, if you will. Don't like the term that much, but if you want to have smart agents or smart machines, that's what you need to allow people to understand these complex enterprises to such a level they can start improving and work these competing goals. So that's why we're in finance, we're in mining, we're in engine shops to maintain engines for BAE Systems and Emirates. Finance, we're in banks and insurance companies. Mining, we're in Lumina, which is a big copper mine in Chile, which is very different environments, but they all use the same version of the software. Yes, we are model-driven. I thought it was a unique thing, but I even are not allowed to mention it, I guess, after the last 2 days. But it's totally model-driven, therefore very agile, and they use it to basically solve the problem of their end-to-end process. We don't think the biggest challenge is just in improving a front office or a mid office or a back office or a transport operation in a mine. We think the biggest gain in terms of productivity and profitability is gained in how these units work together from an end-to-end customer perspective. And most of the applications they build are not designed that way, as is the data that they report. So what did we do? This is the boring stuff, so I'll go over it very fast. We developed an ontology that allows us to make sense out of all of this information that goes around in these big enterprises. Because big data means there's even more data than we used to have, but the challenge is how can you make sense out of it? And therefore we developed technology that allows us to capture the data and reflect what's in the business into a technology environment that can then help us to improve. So therefore we have a model engine in which we reflect what's going on in the real life of these enterprises. We have a data engine that allows us to capture all the data that goes on, whether that's transactions stored or whether that's events in near real time in milliseconds. We can handle it all. And we have the execution engine, BPM kind of execution engine, which helps us to not only analyze and look at the stuff from a dashboard perspective, but we want to act. We want to be able to improve based on the knowledge we are gaining. So therefore, we need execution. We deliver the software to the end users, the business end users, in terms of cockpits. And the methodology we use, we call map, monitor, manage, which basically means map your environment, including strategy, but also including process, to understand what's going on. If you don't understand it, how the hell do you want to improve it? Monitor, Like in your car, you want to be able how fast you're driving before you act, manage. So the ontology is, from a strategy perspective, helping us to have the discussion with the board in terms of, well, what do we want to do? We have been talking about goals, but what is the objective and how are we going to execute in such a way we achieve the objective from a business CXO perspective? So we discuss about who are the stakeholders from a value and constraint perspective. What are the main goals you're aiming for in terms of the value drivers, performance, risk and compliance, and it all ends up in financial results. Which are the results of executing your business model, which is about your customers, which is about the products and services you sell and deliver to those customers, which again are the consequence of executing processes. Processes that are managed and supported, and that have events that trigger those processes, and suppliers can play a role as well. Especially as the world is more specializing, and disciplines are more specializing. More of these processes are outsourced to like networks of companies. But from a managerial perspective, it just adds complexity. And still somebody is responsible for what the customer thinks about it. So in the technology side, it's model-driven. It is integrated by design, and with integrated by design, I mean the 3 core engines that make up this platform. So we have the model engine, in which you can do meta management, master data management. We have the data engine with a full BI stack underneath, 100% model-driven. So nobody is touching this stuff. It's all done by the model. And yes, we can handle big data, which can mean millions of transactions in a bank on a daily basis. But in the mine, it means millions of events per second, because the automated factories and the concentrator and the hydraulic plant just produces vast amounts of event streams that you have to be able to capture as well. And there the execution engine comes into play, because our complex event processing engine is able to do so, but the BPM and workflow part is able to execute as a result of it. And all of this works combined to create the solutions our customers are looking for, referring to the end-to-end problems I just mentioned. So we have some domain layers on top. We have the presentation layer. We do fast integration because we don't do anything else. It's just taking the raw data out of source systems. All of the making sense out of the data is done by the model. So all the knowledge of the company is in the model, and that will make sense out of the data. We don't want to have all kinds of complex integration scenarios with IT, because that will take us years. Well, you do this anyway, because it's what you do every day if you drive your car. You map, you monitor, you manage. It's nothing new. But in companies, people don't have the tools to just work the same way. So what we do is we go to a customer and create a strategic picture to start understanding how this complex enterprise works. They provide the answers, and then this model is building up. So once we have the model, by the way, with model, we can do 3 things. You can just model and key the data in. But from the process perspective, we may import models. We run in a lot of tools like RS and bpmN tools and what have you got. We just import those to generate the models. Or we add the process mining stuff to show, based on the events kicking around the service, how basically the work was executed. And I like the latter one because from a change management perspective, it's easier. Then we tap into the source systems, which may be 5, 12, 20, or even more source systems that all have relevant information about this end-to-end value chain that you want to have in terms of to be able to analyze the performance and start improving. So in the bank that I just showed, we are tapping into 21 source systems, and it contains hours, finances, mortgages, all the stuff that goes around in the bank. And every day we just take out all the raw data. And after a while, yes, that becomes a big volume amount of data. And if you look at the data, and you have this picture, and it's a single picture of truth telling you what's going on, people want to start doing forecasting. They want to have support in terms of decision making, because decision making is about the quality and the timeliness of the decisions. The more rich the environment and the information I have to support my decision, the better the quality of the decision will be, as is time. I didn't mention on the ontology slide, but you saw management cycles as part of the ontology. We support Deming, Plan, Do, Check, Act. But I'm a fan of the OODA loop, which was referred to by Jim Siner before. I'm an Air Force guy. And really go through that process. And the key thing about the OODA loop is if you can do this faster than competition, you'll be more successful. That's the whole key element of doing the OODA loop. And there, execution comes into play because now we're fiddling around with algorithms, with data, in the context of the model. But doing that, creating the forecast and working the data, is a process by its own. So why don't you use the same execution engine? That's what we did. But in the end, you can also automate the execution of processes, which can be in our platform, or you can work together with other bpmN vendors. So this morning, I promised some people to show some stuff related to a presentation last year from Fluxicon. I just heard the name a couple of times again, because we did some work with those people. And basically, this is a few cockpits that we provide to our end users. We'll show a live example, of course, in a minute. But these are screenshots where the process part of the strategic value chain was generated based on process mining tool. In this case, Disco from Fluxicon. And as you can see, we separated, this by the way is a Telefonica company, we separated the information a process mining tool is able to provide you around volumes and throughput times and stuff of the process, but we add much more context to it to support decision making. Because I want to have information as well about the customers and the costs and the dimensions of channel and product, etc. That's what our platform adds to those tools, but also allows you to not only use the tool in a project fashion, but make it part of a continuous effort to improve performance. So here you see the end-to-end process. SAP showed an end-to-end process. That's what we do as well. And per step in the process, you see all the data. And this is basically used to analyze, to better understand where you think the biggest improvements are. And you can fiddle around with BI analytics, and you can do forecasting, and you can apply algorithms to it, basically whatever you want. And this is just one example in which we, of course, also show here all the different variations of this process as delivered to us by the Disco Fluxicon tool. Because if you receive a diagram in RS, it's only 1 or 2. But if you start mining, you'll have 18, or in this case, 80 different versions of the same process. And the question now is, which one should we eliminate to improve performance and lower cost? And this is another example doing the same, not with that tool, but with an algorithm we designed ourselves. And this is put the same principle on top of SAP. So we took the event logs out of SAP, procure to pay, order to cash, those kind of processes, and we generated everything that's on the screen. So you just put our tool on top of SAP, and boom, the cockpits are created automatically. So if we go through for every different version of the process, it's a 9.4%, it's the 4.8%, you will see the workflow changing. You will see, in this case, the transactions codes that SAP is using, and what is the development over time of those codes being used. So now you have the business picture of the process, but also what IT is doing to support the execution of the process. So models can be modeled, generated in different ways, and basically we can do multiple ways. So let's go to some of the live stuff. This is a cockpit. I'm in Google Chrome, and I'm probably kicked out because I have to log in again. Yep. And suppose you are the CEO of a energy company. then this is how your strategic value chain may look like. And you can look at performance from a process, and it will show you what's going on. You may find that your grid is not performing in terms of availability, but hey, I want to look the entire strategic value chain from only this perspective, because this is a lot of information. So let's now just lock and look at the entire value chain only from the perspective of network availability. So I see like, hey, in the Netherlands, I seem to have a problem. Let's look again, and I can see now that in terms of transportation services, 3 are in the red and 1 is in green. So this one is okay, and the other ones are not. What you're looking at is a combination of a model engine and a data engine. This is just the monitoring part. And I don't know how much time we have, but let's make a shortcut. And I'll go to another user, because everybody has a cockpit. This was the CEO. Let's move to the asset manager of the same company. Because if you provide all the information to everybody, it's too much. You want to have it based on governance only for the role or function that you have. So he logs in, and he sees that he has some tasks on his landing page, and this is distributed by a process that you can manipulate the way you want. So that's where the execution engine again kicks in. But if you look at his cockpit, then he wants to look at more operational data and play around with it. So we can just blow it up and do all kinds of analysis, whatever he wants. Or again, he also is senior management enough to have a value chain, which looks differently because his area of responsibility and what he does is different. Or he may be wanting to look at it from a geo perspective. And tomorrow or today I saw a nice picture. So let's put the satellite picture on. Yep, it's basically the same. And you see some red assets. It's a rectifier. And also you can see that, hey, this rectifier had a few failures before. Those were closed, but one failure still has to be assigned, which again, of course, has a process behind it that needs to be managed. And the data may come out of different source systems. And there may be no process execution environment that connects those different types of applications from the end-to-end perspective. And that's where we kick in. Dus even inloggen, Giel. So let's move to the back end, but I want to show you one more thing. We're now in a mine. We put Giel's picture on, so you have a mine manager in place. And of course, he's got a strategic biz map as well, but let's look at the process perspective. We're now drilling into the level of extracting minerals in a mine. And you can see all the steps as part of a workflow. Well, I want to know in terms of risk if I have any problems around, let's say, transport crushing. Well, we don't. There's only one risk. We have one risk profile, and there's one audit finding, whatever. You can, again, log the audit finding in your cockpit. It's all very dynamic. So let's go to process and look at it from a performance perspective. Let's look at transport crushing, and I see a lot of red. And let's look at it from the perspective of volume, because in a mine, volume is absolutely key. Volume and costs. So I can see here the performance. I can see more context for decision making. I can see like incidents. But I could also like drill down and see the asset IDs, whatever I want. But let's move on, because I want to know how I could improve the performance of this process. So let's drive a scenario. Let's again do it in the context of this workflow activity. And let's see what happens. I think I have to reset first. Yep. So this is the current performance. And I'm the manager, and I want to improve. So I start a scenario, and instead of this car driving 58, let's see what happens if it's going to drive at 20 miles an hour. Or use a nice slider and just push update. Now underneath in the engine, based on the model context, an algorithm runs data to provide the result back to the end user. So what happens is, I'm not too happy. This is not what I was looking for, but of course I made him drive less instead of faster. So what I can also do is, if I have to go and look for the optimum, I don't know what it is, and I have to do all of these tryouts. I don't want to do that. But these guys are clever, and they already fix some algorithms that can help you do so. So let's use that algorithm instead of trying to do this ourselves. So let's reset the model. Let's do it again, but now let's push optimize, which is the optimization algorithm this company has in place. And what happens, of course, is, hey, I'm back on track. And the scenario will tell me what the parameters are in their optimal settings. Now, basically, I've just been playing around with process, data, algorithm, and model. No more than that. It's a very generic concept in a generic platform, and you can basically do any kinds of stuff with it, including this one. How this actually works is going to be shown by Giel.
If there is still some time left.
2 or 3 minutes. Okay, let's try to do that. What I really want to show is the back end of it, is how this all being fabricated. I think the first difference in our solution is that we leverage on Microsoft technology. So the entire platform that you have been seeing is based on the Microsoft stack, compared to a lot of other products we have been seeing over the last couple of days. Let me see if I can get this connection up and running. Yes, here we go. What we're looking at right now is our designer environment. In this environment, I've loaded 2 engines. We have the execution engine up and running with a separate set of activities. And what I can open here, this is the example that Alfred just was running. What we see here, this is the true execution process. So this is not the BPM model that could be used to import it. This is the true execution model, a more simplified version of it. But then you can add all the details that are needed to make it execute, of course. One of the things I can show you here is that we query the database. And basically what we're running here is we have a process running that queries the data warehouse database directly to receive some values from it and use those values within the optimizer process. It does that a couple of times, and then it comes here a little bit deeper into a presentation mode where it's going to show a screen to the end user. And basically, Alfred showed that he had some buttons to click on and some sliders to manipulate. Now, the sliders were preloaded from the data warehouse. You can manipulate those and then choose a continuation path. One of those was the optimize button, where eventually an algorithm kicked in to support him. What we do within our execution platform is we leverage on new compiler technology from Microsoft to maximize, of course, quality attributes of our platform in terms of performance and reliability. The nice thing about that is that you can inject snippets of code within your environment. So basically what's been laid out here is a IntelliSense auto-completion driven design environment where we've injected an algorithm that has been crafted by some guy that has a whole lot more of knowledge about how to do that than I have. So really an expert came up with this algorithm that could support that mining scenario. We injected that, but of course a lot of the BI capabilities do offer default algorithms to reuse. Here in the back is that eventually the data warehouse gets updated with the chosen path, and then the presentation layer of the cockpit gets updated as well. In terms of activities, we have default control structures, of course, ways to manipulate the object model, to use it, and to change it. This is to manipulate the task list. We had already different examples shown where we were able to provide tasks. We can do that as well within the process. That could trigger different processes. But one of the nice things here I personally like is to be able to use business intelligence capabilities directly within the process execution. And then we can fire off ETL packages. We can load the data that has been packaged into the data warehouse. We can process cubes. We can query values also multidimensional. Like SAP was showing that they have this nice SAP HANA capability where you can fire MDX statements at. We can retrieve those results from SAP HANA or another OLAP system to use that within the decisions of our process. The nice thing we also have is we can publish back into the BI stack. So the system is model-driven, but we can also model how the structure of a BI environment should look like, and then publish the deltas, the differences, back into the infrastructure, because it takes a lot of work to synchronize a good BI stack, including a OLAP server. This is traditional database, similar, but SQL style. Some document management capabilities, some messaging, of course, influencing the user interface and authorization, authentication style of activities. Secondly, what we have is complex event processing. Alfred already mentioned it, but time-wise, it's not able to show it, but we can run SAP processes as well to manage the incoming event stream. This is also compiler-based. We can really push into the millions of events per second if the algorithms is fair enough per thread. And the second nice thing I can show you here, this is at the heart of the model engine, is where we manage the object structure and the ontology, as Alfred just mentioned it, and the meta environment. And here we basically can create or extend objects of the system. And yesterday I was on the table and they were talking about a system that uses meta technology to describe itself. I found this really keen. This is especially what we do as well. Here I can go into the business modeling aspect, and then I can open the meta of the process, the workflow environment itself. So this is the tool describing itself with activities and swimming lanes and flows underneath. We extended it with the iCore, so we related it to functions or roles within the organization and to see what's going in and out of the processes. But of course there are also namespaces regarding all the performance management or the risk and compliancy and SLM management. Okay, I believe that's time-wise, that's it for now.
Thank you very much.
Thanks a lot for that. Yes.